So we are now going to look at the operation ya Hydroset. Napakuvala, we're going to basically just collect the anticipated required conditional inputs. Okay. So we're going to start from the power circuit. Then we're going to view these side by side. Okay. This Hydroset diagram and then the power circuit. From the power circuit, we need to come to where it says Hydroset, which is this one here. Okay. So on the Hydroset, we need to create auxiliary contacts for the magnetic tripping. Okay. So create a group. I believe we just need normally open contacts. Okay. So we go normally open contact, and then we need to save this, and then thermal overload. We're going to create a group which is normally open, and then of course for the residue protection or residue current device, we're going to create a group which is another normally open contact. Okay. So when this is done, we need only drag these onto the Hydroset diagram, and I believe we also need the auxiliary contact for the main breaker MC. Okay, we need to create another one. So here we need to create a group. Is it this one? Why doesn't it have anything attached? Okay, it's this one here. We need to create another group, normally open. Then we're just going to say okay. Then we're going to close this. Then bring this associated contact onto our Hydroset diagram. Okay. Then I don't think we need to look at this anymore. Okay, so what else do we need? I think we're going to need also the lamps. Okay, signaling devices, we need an indicator lamp. Okay, we need an indicator lamp, then a valve, solenoid valve. Okay, solenoid, we need a solenoid valve. So solenoid valve, okay, we need this one here. Need a solenoid valve. I don't want to associate this to anything, so let's see. Solenoid valve. So what are you rated for? Data. Control voltages, operating voltage is 220 volts. Operating voltage, rated voltage, operating voltage. Rated voltage. What's this? The rated voltage is the component's working voltage. Really, operating voltage. Release voltage, I don't know, but release voltage is, I don't know, rated voltage. So let's see. I hope these values make sense somehow. Okay. In data, this one here. Might as well say solenoid valve because that's what it says on the diagram. So this is what we have. Okay. Then thereafter, is there another solenoid valve AC/DC? So maybe I should have picked this now. The IEC type. Okay, let's see. I think I like this one better. Okay. pick this one instead. You can pick this one. Then the operating voltage. Could I choose, let's say, can I pick maximum operating voltage as 150? Okay. Could I then pick the operating voltage of 120, the rated voltage, same as the operating voltage, then the release voltage, lower voltage, if the voltage is lower than 80, or maybe a release voltage of 100. Okay. Hopefully this works. Okay. Data is KH. So solenoid valve AC/DC. Okay. Solenoid valve 1. So let's get rid of this one here, because I think I like this one better. First thing we need is an input link. Okay, so links, I think it's this one. We need an input link. Then this one is going to be linked to L3, because I don't really think we've used L3. The designation is supposed to be L3. Okay. Come on, I need all caps. Need L3. So transformation, rotate left. Okay. So this is the beginning of our circuit as L3, and then of course we also need N3. Okay. Association should be N3, and then data item identifier is N3. MC is this MC here. This is the MC, then followed by 4CE3, which is this one here. Okay. Thereafter we've got 4CD1. We're not going to do 4CD1 because 4CD1 is coming from the overload and the earth leakage. Okay. So what it is okay, so we need 4CE3 like so, and then transformation, rotate left. Okay, I'm going to have it like so. And then what else do we need? Okay, then this earth leakage, transformation, rotate left. Come here. So we've got overload, the magnetic tripping, and the earth leakage. Then additionally, we're going to target 4CD1. Okay? So 4CD1, did we create 4CD1? I don't think so. So we need to copy a coil. Okay, you can copy this one. Transformation, rotate left. No, this is not a power contactor coil, but it's supposed to be a control relay. Okay, relay coil. Transformation, rotate left. And then this is going to be 4CD1. Okay, this is going to be 4 for CD1. And of course the control voltage should be 120. Okay, it's 120. So that's done. That's for CD1. So for CD1, then we need an indicator lamp which is for CH1. So this one here, transformation, rotate right, we'll bring it there. This is for CH1. Okay, this designation is for CH1. Oh, come on. This is for CH1. Then thereafter we need 4CH2. We need 4CH2. Then what else do we have? We have 4CH1, 4CH2. We need a fault reset. Like I said previously, we'd used a fault reset in which circuit was that? Okay. Hopefully it's there. So we need to create another one, another associated contact for reset. Okay. Normally open contact, normally close contact, normally close contact. Anyway, we'll pick this one. I don't know, maybe whatever this says, but so we'll pick on this type. Okay. So we need this in this position in the document for the Hydroset. So this is our 4cc1, 4cc2. Okay. And then of course we're saying that, okay, because these two are essentially the same configuration. This is 4cc2, 4cc1, 4cc2, 4cc1, 4cc2. Anyway, doesn't really hurt. So contact group normally open, another group normally open. Okay, and then we just save this, and then 4cc2 normally open, another group normally open. Okay, then of course I know this is like I know this is 4cc2. No, this is 4. And this is 4cc2. Then this other one was 4cc1. Okay, we have 4cc1, 4cc2, the solenoid valve, and thereafter HDR. Okay, so HDR should be right about here somewhere. Okay, so this is our HDR, and then HDR we expect to have two contact groups. One is normally closed. Okay, one a normally closed group, then the other one a normally open group. Okay, so normally open, normally closed, and then we have two indicator lamps. Okay, so we have one here, and then we need to create a copy of this. So basically the HDR, okay, this is HDR, it's controlled by a Hydroset pressure switch. So under normal conditions, this switch is supposed to be closed. Okay, so when this switch is closed, the normally closed contact, okay, meaning this other one is going to be normally open auxiliary contact of the HDR control relay is going to be closed. So this is HDR. Okay, so this one here as an indicator lamp is going to be HDR, okay, which is going to run in green, okay, in a bright green. And then this other indicator lamp, okay, this other one is going to be HDR fault, okay, it's going to be HDR fault, and it's going to run in red. Okay, we're not going to change anything. The control voltage is just 120, so we're done. And then of course we need a toggle switch. Okay, we need a toggle switch and we need a siren. So loads, okay, let's look at signaling devices, and then we're looking for an alarm. Okay, and then buzzer, siren, horn, anyway, whichever one, it doesn't really matter, but we'll get ourselves a siren, and this is going to be the Hydroset low pressure siren. Okay, this one is going to be Hydroset low pressure. This is going to be the Hydroset low pressure siren, which is what this relay alarm is. Okay, this is a Hydroset low pressure siren, and then we need a toggle switch. Okay, this alarm console, we need to come under switches, and then don't we have a toggle switch? Toggle switch with brake contact, manual, return. So we will need a toggle switch. We need a toggle switch, or maybe let's get the IEC one. Okay, so this is going to be our toggle switch, which is alarm console. Okay, and this one we're going to change the item identifier to alarm console. Okay, so I've done this one, and then going further out right, we're going to have a start siren near remote operator's desk. So essentially this is one of the restart warning sirens. Okay, so essentially we just need to copy this, and then what we're going to say is we're going to say remote station siren. Okay, so now that we've got all the necessary coils and contacts and whatnot, the only thing we need to do is we just connect them together. Okay, so this is MC, like we've been doing previously, right? So one end of MC is going to connect it to the live end of the control voltage. Okay, thereafter we need 4CE3, which is normally closed. Okay, so apparently we needed 4CE3 as a normally closed auxiliary contact. So maybe we can go back to the power circuit. We need the Hydroset. Okay, so we need this Hydroset, and then we need an auxiliary contact of the thermal overload, which is normally closed. Okay, so we're going to create a contact group which is normally closed. Okay, and then just accept. Then we're going to take this onto our Hydroset page. Like so. All right. So we have 4CE3 right after MC. Okay, so transformation, rotate left, position, and then we have raise and lower. Okay, these are switches. Okay, so push button switch with make contact, automatic return. We need two of these. So transformation, rotate left. So this first one, okay, first, okay, let's create two of these. Okay, the first one will be raise. The first one will be raise. Then the next one will be lower. Okay, this other one will be lower. So raise, lower, and thereafter auxiliary contacts of 4CC1 and 4CC2. Okay, normally open contacts, or rather normally closed contacts, right? So let's see. Okay, so let's get the coils as okay. So this is 4CC1, 4CC2. We know what these are for. Okay, they're for later, but we need to bring this to the left. Okay, so transformation, rotate left. So the first one is going to be 4CC1. Okay, so this is our 4CC1, then 4CC2. So alignment, align bottom align, and we can maybe push them down a bit. Then we need to interlock them with our normally closed contacts. So we need to create a contact group. Okay, which is normally closed. Okay, which is normally closed. And then with this other one, we're going to create a contact group which is normally closed. Okay. Okay, so that's done. So transformation, rotate left. That's 4CC1, normally closed. It's going to interlock the control of 4CC2. Okay. Then transformation, rotate left. This normally closed auxiliary contact of 4CC2 is going to interlock the operation of 4CC1, like so. And this takes care of this part. Okay, so the only thing that we have not taken care of is HDR. Okay, so HDR was thrown to the left side. Okay, so HDR can be here. Doesn't really matter. It can even be after this, which is why I think we need to maybe position it. Okay, doesn't really matter. We can just as well put HDR here. And then as before, we need to simulate the the Hydroset pressure switch. So to do that, we just need to use an emergency push button, okay, with the brake contact. Okay, that's just what we need to do. Then transformation, rotate left. It can come here, or it can go there, or we just return the configuration. So maybe we can just pull back on the input links. Okay, then thereafter we can put the Hydroset in this position with the simulation switch. Okay, this one comes there, so that now we have this. Okay, and then we can just link these together. Yeah. So this one here is the Hydroset pressure switch, just to help us simulate the circuit. Okay, this is going to be Hydroset pressure switch. Okay, so this right here is the Hydroset pressure switch. So we've done all this bit. Okay, we've done all this bit, and then of course what comes after that, we've already arranged these protective devices, okay, for protective auxiliary contacts. So we don't need to talk about 4cc1. Why do I have to? What's your 4cc1, 4cc2? Anyway, we'll take care of this when the time comes, but I already have 4cc1. So then what we're going to do is we're going to link this up. Okay, so we have this, and then we have the system-wide fault reset, so which we kind of hope is this one. Okay, so okay, so after this position, I'm talking about a fault reset position. Okay, and thereafter we're talking about 4CD1. Okay, so we're going to connect this point to that point, and then the end of this is going to be connected to 4CD1, and then of course we can do a little bit of alignment. Then this coil and this coil are going to be aligned bottom aligned. Okay, then connect to the neutral end of the control supply. So we've taken care of this branch. Okay, so in 4CD1 we need to give us a normally closed auxiliary contact. Okay, we need a normally closed auxiliary contact. which we're going to use to interlock the second rung. Okay, so 4CD3, 4CD1, so transformation, rotate left, come on, transformation, rotate left, so this comes here. Okay. It's normally closed. Okay. So maybe I need to pick this one, and this one. Distribute vertically. Okay. I think this is better. Then maybe I need to move this a little bit down. Okay. Then these distribute. So this, and that distribute vertically. Okay, which is pretty much fine. Okay. Then move this a little bit down. Anyhow, so that takes care of 4CD1. Then the raise lower, then the 4cc2, then 4cc1, 4cc1, 4cc2. I'm not going to bother with the port names now. I'm tired. Okay, so taken care of. Okay, let's see, port reset, 4CD1, then across from Then across from 4CD1, we've got 4CH1. Okay, so 4CH1 is hydroset fort. Okay, so 4CH1, do we have a comment? This is hydroset fort. (4CH1) is hydroset fort. Then 4CH2, this 4CH2 is hydroset running. Okay, is hydroset. Is hydroset running. The reason why this is hydroset running, because it's linked to 4cc1 and 4cc2. Now 4cc1 and 4cc2 are energized if you want to go to raise the hydroset or you want to lower the hydroset. So basically this is hydroset running. Okay, so transformation, rotate left. So this is the hydroset. Okay, maybe I can put this side. Transformation, rotate left as hydroset fort, and then this one as hydroset running. Okay, so for the hydroset fort, we just connect it across this position, and then one end is connected to the neutral end of the supply. Then thereafter, we're talking about 4cc1 across from 4cc2. So transformation, rotate left, that's 4cc1, then transformation, rotate left, which is basically 4cc2, like so. And then on one end, these are connected together, right? Then one end of this is connected to one end of the live supply, okay? To one end of the control, which is the live end, okay? Then on this other end, we need to come and connect to this indicator lamp, okay? So let's see. Then this one here, or rather I pick this as a reference, then together with this one, alignment middle align, so that it moves up, okay? Then connect this end to the neutral end of the control, okay? Then thereafter we can just move this a little bit to the right to create more space in between them. So this is 4cc2, and then it's connected right across from 4cc1, okay? So we've taken care of this end. Then we need to do the same thing for the solenoid valve, okay? We need to do the same thing for the solenoid valve. So it's kind of a mess actually. So again, we need 4cc1 across from 4cc2, okay? Oh, don't need to move the label alone, but need to move the whole arrangement. Could we have this one and these, okay? Alignment, bottom align maybe. Then distribute horizontally, okay? So now that they're evenly spaced. So again, this is connected to one end of the control, which is live, okay? Like so. What am I doing? Okay, this is targeted towards the solenoid valve, okay? So we need our solenoid valve in this position, so that now we have something like this, okay? So this end is connected to the neutral end of the control, okay? Then I guess this is the same thing, connected across from 4cc1, so 4cc1 and 4cc2. So I need this and that, alignment, bottom align, okay? So the solenoid valve is controlled, this solenoid valve. Okay, so we're able to control the solenoid valve. So we move on to the hydroset. So one should be normally close contact of the hydroset, the other one should be normally open, one normally closed. So I don't know, why do I have two normally open contacts? So I need one of these to be normally closed. Okay, like so. So transformation, rotate left. So we come here, transformation, rotate left, like this. And then of course, like I said, one is for hydroset okay, the other one is for hydroset fault. So the normally open contact is hydroset okay for this one here. Okay, then the normally closed contact is for hydroset fault. Is for hydroset fault. So we have this here, like so. So we just need to alignment, middle align. Okay, so it's for this part. So like so. Okay, so this takes care of the situation of the hydroset okay and the hydroset fault. So now we just need to rig the hydroset low pressure siren. So transformation, rotate right, like so. So hydroset low pressure siren. So this label, transformation, rotate right, like so, hydroset low pressure siren. And then we need the toggle switch. So transformation, rotate right. It's going to come like right about, should be maybe down here. So this is what we have. Okay, then this is basically just linked to this position. Now, could we try to maybe move these up? Okay, so then this other end comes here, then this other end gets connected to the neutral end of the supply. So we have this arrangement now and it's done. So the only thing we need to create now is for the siren. So the siren, according to them, it's working off of a 220 volts AC supply. Okay, then we've got the associated auxiliary contact of the relay RR. Okay, so what do we do? If it's on this station, so transformation, rotate right, going to do it like so. And then of course we need RR. But as opposed to using 220, I think I'm just going to use 110 because we already have a supply for 120. Okay, that was in the lubrication control if I'm not mistaken. So let's look for RR. Okay, so RR is this one here. Okay, I'm going to create a contact group, one which is normally open, okay, we're going to go with 2-pole. Okay, what's the rated voltage for this? 600 is adequate. Okay, so that's RR. And then what we're going to do is we need this in the Hydroset circuit. Okay, so transformation, rotate right, maybe we needed to separate them a bit. Okay, we can look for protection. Okay, protection. No protection. Fuse switch would disconnect one pole. Okay, fuse switch with fuse. So pole plus neutral. Maybe let's go with this one. Okay. So transformation, rotate right. We're going to come here. And then we're going to come to, okay, we're just from using what? This is the Hydroset, and we've used L3, so L4 is open. Okay, so we just need links. Okay, we need an input link, in that position linked to the neutral, which is N4. Okay, N4 as a neutral. So data N4 is the neutral. Okay, and then for this other one, that's the live end. This is going to be L4. That's the L4 as the live. Okay, so association is going to be linked to L4. It's going to be linked to this. Okay, so that does it. Then the only thing we need to do is maybe do I reduce this? Okay, so the space between them, maybe let's see what happens with this one. Too small, but so this is our RR. So we just need to link these 2 points. Okay, and then for this one here, we're going to prefer that it's closed upon commencing simulation. Okay, so close on simulation. Okay, then the true value, you need to mark this or it's not going to work. Okay, that's what we get, so that when we do say simulate, this is supposed to start with this position closed. Okay, so right now we're saying that the hydroset is okay, the serine is off, and then what do we need also? Okay, so what we're saying is that right now the hydroset is okay and the hydroset 40 lamp indicator is off. But if the hydroset pressure wasn't adequate, what it would mean is the hydroset 40 indicator lamp would come on, and then for you to switch off the hydroset low pressure serine, you need to toggle this switch, okay, so that the serine comes off but the pressure is still low. Okay, so when you normalize the hydroset pressure, so all you need to do is toggle the switch back, okay, like this. So that's how the system is going to work. And then additionally, you'd notice that you can either raise the hydroset, okay, you can raise the hydroset, and apparently the solenoid is not coming on. Why are you not? Or we made some mistakes along the way. It's supposed to be AC. So it's 120. So why are you not coming on? Okay, so let's see. Come on, kind of solenoid valve. Operating voltage is 120, so let's see. Operating voltage is 110. I hope this fixes the problem, so that the rated voltage is 120, the release voltage is 100. So let's look at that once more. So now it's able to work. So the solenoid valve comes on, and then once we're raising, we can't lower. Okay, so even if we press this, nothing happens because there's a double interlock thing going on. Okay, so we need to stop raising for us to lower. Okay, in which case you get the hydroset running. We would want for this to be in green. Okay, hydroset running, you want this to be running in green. Okay, so let's do that again. So hydroset run. So the hydroset is running, then the solenoid valve is also open. And then if we have a low pressure for the hydroset, okay, should the hydroset pressure drop, okay, then you're going to have this serine coming on. Okay, this hydroset low pressure serine will come on, and then the hydroset 40 indicator lamp will also come on, so that you know the system pressure for the hydroset is not okay. So this basically completes this particular configuration. Okay, this is how this thing would be. So for the hydroset, we're done. Okay, then the next part, okay, before we even do anything else, remember when we were starting out, we did remove the hydroset auxiliary contact from the emergency, or rather from the safety relay. Okay, so maybe we need to go back to where this whole thing started, not the power circuit. Which one is this? Okay, and I think this is the one where we need to put back the the associated auxiliary contact for the Hydroset. Okay. So we need to put back the HDR auxiliary contact. So we need to put back this one now, because now we have the controlling relay. Okay, so HDR comes back into the circuit, because if we get into simulation, we need only look at this contact in relation to HDR. Okay, in relation to this HDR. So if the hydroset pressure is low, this will be de-energized. The safety relay will get into a faulted state. So meaning you can't start your system, because wherever it's used as normally open, that part of the circuit will be open. Okay, so that's why this was important. Okay, so that takes care of that, and this is where we end with this. And then the last section we just look at the vibrators.